Hello everyone, I guess we'll get started here. So welcome to the fifth webinar in a series of 8 for the Forestry Adaptation Community of Practice. For those of you who don't know me, my name is Annette Morand and I am the facilitator of the online adaptation communities of practice. And we run those here at OKR, which is the Ontario Centre for Climate Impacts and Adaptation Resources, and we're located at Laurentian University in Sudbury, Ontario. So the way the webinar will run is as follows. So after this very short introduction, we'll have the main presentation, which will go for about 40 to 45 minutes. And then at the end of the webinar, we'll have some time left over for any questions that you might have for the presenter. So if you have any questions during the webinar, we just ask that you please do hold them until the end. And before we get going, I just have a few housekeeping items to go over. So first, for those of you who dialed into the conference call line, your lines have been automatically muted, and the reason for this is just to avoid any audio distractions or feedback, etc. during the webinar. So to ask a question during the question and answer period, all you'll have to do is dial *6 and that will unmute your lines, but please do keep your lines muted during the presentation. Also, you'll notice that there's a chat box on the left-hand side of your screen. So you can use this chat box to field any questions that you might have for the presenter during the question and answer period. As well, if you have any technical difficulties during the webinar, you can also use this chat area to type your message, or you can click on my name and send me a private message, and I can try to help you as best as I can. I also want to mention that we are recording the webinar today, and I'll be sending out a copy of the recording to all those who have pre-registered with me, and we'll also be posting it to the Community of Practice website. And finally, I know we have some people on the line today who may not be familiar with what the Forestry Adaptation Community of Practice is, or the FACOP. So I wanted to take this opportunity to quickly mention that it's an interactive online community, and it's dedicated to those who are working in forestry or for those interested in forestry and climate change adaptation in Canada. It includes features such as news articles, events, an online library packed full of resources, as well as discussion forums and much more. So it's free to join. So if there's anyone on the line who's interested in learning more about the FACOP, please just click on the link in the chat box there for more information and to register. So with that being said, unfortunately, Gary Nielsen was unable to join us today due to a scheduling conflict with another meeting, but we're very excited to have Jenny Gleeson on the line with us today to talk about the climate change ecosystem vulnerability in Great Lakes Basin. And just so you know a little bit more about your presenter, Jenny is the Senior Climate Change Program Advisor for the Ontario Ministry of Natural Resources and Forestry. She's been involved in international and national climate change policy and actions, including working with the International Institute for Sustainable Development on climate change mitigation and adaptation issues. She holds a master's degree in international development studies from the University of Amsterdam and a bachelor's degree in international development studies and environmental resource studies from Trent University. So on behalf of everyone joining us, I'd like to extend a very warm welcome to you, Jenny, for taking the time to present this webinar for us today. It's very much appreciated. So without further ado, I will now turn things over to you.
Okay, thanks, Annette, and thanks for everyone for joining today. What I'm going to be describing today is a bit of a beginning of a multi-year journey of a regional adaptation planning process that I'll describe. It's not specifically forestry focused per se, but it attempts to capture all sort of ecosystem components of a vulnerability and adaptation planning process. So hopefully participants in the webinar may see ways that they may want to be connected with the project, or perhaps some lessons that I'll describe that we've learned to date that may be applicable to the context that some of the participants are working within in their own jurisdiction. So what I'll go through today is a little bit of context of the Great Lakes Basin ecosystems and climate, some of the strategic direction and methodologies that we're using in this project, some case studies from Ontario of vulnerability and adaptation planning that we've been involved in that sort of led us to where we are today, which really is a bit of a view of where ecosystem-based adaptation efforts currently are in Ontario. And then I'm going to go specifically into this project. I'll give us some examples of some of the research being conducted and where we're hoping for this project to go into the future. So just to sort of locate ourselves, what do we mean by the Great Lakes Basin? We're trying to be as holistic as possible. So I'll just toggle between the full US, Canadian, and Quebec basin boundaries and then the ones for Ontario. So it is a large portion of Ontario, and wherever possible, we're encouraging these research projects that we're engaged in to look at the whole basin and to include the sometimes forgotten about Ottawa River Basin and St. Lawrence River portion of the basin. So it is a good chunk of Ontario that we're focusing on a regional basis. From a people or a human perspective, the basin is a critically important part of our Ontario economy. So 98% of our population live in the basin. 80% of our population gets their drinking water from the lakes. There's a cottaging, an active cottaging along the shoreline. We've got a lot of anglers that come to the lakes, as well as an active commercial fishery. For example, in Lake Erie, there's a yellow perch and walleye fishery that's one of the largest and most valuable in North America. The Great Lakes are used for shipping, so there's a lot of transportation of cargo through the lakes. The southern portion of the basin is quite different than the northern portion. So the southern portion faces a lot of land use pressure and urban development. So just as a comparison, in the southern part of the basin, there's about 20% of the area is remaining natural cover, whereas in the northern portion, you're looking at somewhere around the 90% of the area remaining unaltered and consisting primarily of forests and wetlands. So there's also a number of First Nations living in this basin that are involved in natural resource management and hunting and fishing. So if we look at it from an ecological perspective, as I said, it is a very large watershed basin, so it has very diverse climate, soils, and topography. So in the north, you're looking at a colder climate and a terrain that's dominated by the Canadian Shield, and as a result, there's conifers that dominate those forests. The south, the climate is quite a bit warmer, soils are fertile, and there's much more agriculture and urban areas in this area. And the Carolinian and Great Lakes St. Lawrence deciduous forests make up the main forest in the southern portion of the basin. We've got 18% of the world's surface freshwater is part of the Great Lakes. So obviously this is a huge global significance. And we've got several important coastal dunes, and as a result, shorebird habitats and provincially rare species that are located in the basin. So, you know, we're looking at sort of a diversity of ecosystems. So when we think about vulnerability, we're really sort of challenged to look at a number of different circumstances and dynamics in ecosystems. So finally, from a climate perspective, given the importance of the lakes themselves in driving climate, we obviously need to consider the lakes in studying the effects of climate change. So this image from Environment Canada just shows some examples of the influence that the lakes have on the climate. So for example, the lakes moderate temperatures compared to areas of similar latitude around the world. So you can see the top right corner, the frost-free period of southern Ontario is driven by or affected by the lake effect. Similarly, if you look at the bottom right on precipitation in snowbelt areas, there's a substantial lake effect snow. So like we saw in Buffalo in November, there is a large snowbelt area as a result of the effects of the lakes. Precipitation as well, you can see in that lower right-hand box, you can see elevation of the Algonquin Highlands. You can see the Niagara Escarpment in terms of the changes and the effects on precipitation in those areas. So in terms of what we're experiencing in climate change, due to climate change, we know that it's already occurring in Ontario, and you can see sort of the difference in the southern portion of the basin versus the northern portion of the basin. This is just divided up by ecozone, but you can sort of get a sense of the changes that have already been experienced in the Great Lakes Basin as a result of climate change. So 40 years of data show that definitely minimum temperatures are showing some very significant increases, anywhere between 1.4 and 3.8 degrees change. Rainfall patterns are changing as well, although it is, only slightly becoming a little bit wetter in parts of the province. And this is having an effect on ecosystems in the Great Lakes Basin. So here's 4 different examples of what monitoring and research efforts here in Ontario have shown in terms of observable change in that has been connected to climate change. So there's an orchid species native to the southern portion of the basin that has expanded quite substantially northward beyond its historic range due to its high seed dispersal ability. So it's been able to migrate and sort of find the climate that it needs because its seeds can sort of go with the wind from the lakes. Flying squirrels is another example, and it's quite an interesting one where we've seen a southern species of flying squirrel migrating or expanding northward into the range of a sister species. It's called the northern flying squirrel. And what has been documented in the Kawarsas region is a new hybridization zone where these 2 species are hybridizing and forming a new species. We've had some work conducted recently with the University of Toronto that's demonstrated over the past 30 years fish range shifts anywhere between 12 and 17 kilometers per decade over the last 30 years. And the greatest shifts that have been observed have been these 3 species noted here, the bluegill, brown bullhead, and the largemouth bass, although many other species have also migrated quite significantly northward. And the final example that I'll talk about is just, very, very important to the Great Lakes themselves, which is dramatically less ice cover in terms of the duration and the coverage itself. So there's been 40% decline in the area of Lake Ontario covered in ice since 1970. And I just picked that one out. There's been similar trends in the other lakes with different percentages, but this is just one example. So the trends are showing earlier breakup and later freeze up overall. So we also want to look at projections forward, and we use climate models to do that. And this is sort of just an interesting take on looking at what climate models are telling us. So we know that climatic conditions are going to be on the move, and that's going to affect how species and ecosystems are shaped. And so we've mapped out the climatic conditions for various ecoregions across Ontario. This is the brown line shows the ecoregional boundary for 6E, which is sort of the southern portion of the Great Lakes Basin. And the dark orange represents the core climatic conditions for that ecoregion. And I'm just going to toggle through, this is the current conditions, obviously very representative of that ecoregion. And this is projections using climate models for the 2020s, the 2050s, and then finally the 2080s. And so what you see is the core climatic envelope for what we currently experience in the ecoregion of southern Ontario to be up north of, in the Wawa Marathon Thunder Bay area. So, that has a significant that's a significant piece of information for natural resource practitioners who are thinking and planning, out on 50 years, 100 years, and the decisions that they make, that the climate might be quite a bit different. So in terms of some of the strategic direction guiding us to what the work we're doing right now, there's the acronym here, sorry about that, it's the Great Lakes Water Quality Agreement. And this is a US-Canada agreement that Ontario then participates in. And there was a recent addition of a climate change annex to that agreement. So very great, and it's helped us sort of drive action under this agreement. So I won't read through these commitments, but just to say that there's an interest in looking at climate change impacts, helping communities and users adapt to the impacts of climate change. Flowing out of the Great Lakes Water Quality Agreement, Ontario has an agreement with Canada called the Canada-Ontario Agreement on the Great Lakes Water Quality and Ecosystem Health. That's the image on your left. There's 3 other provincial strategies I won't go into in any detail, but just suffice to say we have sufficient and plenty of direction from multiple sources that are suggesting that we look at climate impacts and that we undertake vulnerability assessments in a way that we can inform adaptive management decisions. So these are all sort of the strategic direction that has enabled us to do the work that I'll be describing. So to get things started, as a starting point, before we got off too quickly on this project, we wanted to make sure that the work we did was grounded in being as strategic as possible. So we recognize that there's been a lot of climate modeling and a lot of research that's been conducted over the past 10 years in the Great Lakes Basin and elsewhere. So we partnered with the Ontario Climate Consortium, have been looking at what we're calling a state of climate science in the Great Lakes Basin, which is a systematic literature review, compilation of a database of the academic and gray literature on climate impacts in the Great Lakes Basin. And really this is trying to describe and capture that research in a time-stamped state of knowledge. There is an emphasis on the past 5 years, though the narrative of the impacts goes back beyond that. And these images at the bottom are just some examples of some of the analysis that was conducted to look at how are climate models being used in Great Lakes Basin studies. It sort of captures some of the analysis of over 300 studies. So we know that if we want to do additional research, we want to make sure that it's helping to fill knowledge gaps that maybe haven't been pursued very actively. And I'll go over those in a few slides. So just to highlight some of a few examples of very strong and existing research that we will sort of springboard off of in this project. This is an example of 3 different studies looking at Great Lakes water temperatures. So the graph on the top right just shows the different lakes and the projections forward using climate models that show that by the 2050s and the 2100s, we will see significantly warmer Great Lakes surface water temperatures. Lake Erie being the least amount of change and Lake Superior being the most dramatic amount of change in terms of warming. We've had other related studies looking at the changes to stratification of the lakes, suggesting that the length of the lake stratification season will increase, making the sort of cold water habitat, habitat for cold water fish, reduced because the preferred sort of temperature range is going to be quite a bit deeper. And then a study, the bottom right image, is from a study that just came out a couple weeks back, actually, specifically looking at the nearshore and some of the projections for water temperatures, and explaining that site characteristics of the nearshore are very important. So this image just shows different points along the Great Lakes, Kincardine being one of them, Kingston being another, where there's different sort of conditions, and making some projections forward in terms of the water temperatures on the near shore. So looking then at sort of water quality issues, recreation, and water intake impacts. The second example of research that the State of Climate Science report is going to show is a pretty strong amount of research on ice cover and open water duration. So this is an example of some work that was done by U of T and MNRF on the timing of the ice breakup and freeze-up dates. So this first set of images is the change in freeze-up date for the southern portion of the Great Lakes Basin, and you can see here that the freeze-up is going to occur anywhere between 10 and 14 days later in the season. And I flipped to an area near Thunder Bay on the Lake Superior shores, where the breakup, an example of the change of timing of breakup that is projected to occur 8 to 9 days earlier. So overall, we're seeing a greater season of open water duration. And the study also looked at ice thickness as well, showing that it will decrease, obviously. So the third example that I'll go into is related to forestry. It's a study that was completed last year about specifically looking at white pine and the range across North America. So it's showing that white pine is highly vulnerable to climate change. You can see the current range in the middle image, and then a projection in 2060s where you can see the reds and oranges depicting sort of high likelihood of vulnerability, and then the fact that they won't necessarily be able to survive in those parts of the current range. So for the southern portion of the Great Lakes Basin, obviously those populations are at high risk. So all of this is being assembled into a report that's trying to articulate what we know about the impacts of climate change currently in the basin. And we've engaged a number of researchers and experts around the basin to describe what and articulate what they think the state of knowledge and the confidence in data is currently. So this is just two examples of individual and then group consensus input on lake water temperatures and habitat alteration for wildlife in terms of how confident are we. This is using IPCC guidelines on confidence determinations, where subject matter experts feel we are. Do we have a lot of evidence? Do we have a large volume of evidence? Is the consistency or the agreement of results high? And we also asked people to identify large gaps or limitations to the research. So you can see, for example, in lake water temperature, there's quite a few studies available, and all of the studies are generally quite consistent in the projections that they're showing. Whereas the habitat for wildlife, you can see there's a little bit more of a scattering of the individual inputs and a generally lower group consensus on the availability of existing information on projections and the consistency of the results. So this has sort of led us to a notional set of research gaps that we hope will sort of guide the work that we do in the years to come, and hopefully other groups that are investing in research around the basin. So some of the major research gaps that have been identified have included hydrology, wetlands, water levels, forests, invasive species, and genetics. And I won't go into any detail there, but just suffice to say that these are this exercise is helping to inform our investment in vulnerability assessment work going forward. So I've used the word vulnerability assessment quite a bit already without having articulated what we mean by that. So this is an image of a guidebook that we put out a couple years ago, partnering with OPR as a practitioner's guide to climate change adaptation in Ontario's ecosystems. And this image is just a little bit of a schematic of the process that we suggest people go through to look at vulnerabilities and apply climate models and ultimately identify adaptation options that they can implement. We put this out knowing that there was quite a wealth of information on the built infrastructure side, but for forestry and for ecosystem-based vulnerability assessment guidance, there was quite a limited information available. So we felt it was important for practitioners to have something to go from. So really, what we see as vulnerability assessments is any sort of science-based activities, research, modeling, monitoring, that identifies or evaluates the degree to which natural resources or other values are likely to be affected by climate change. So it's quite a broad notion of what it is. As I said, it was developed by MNRF and OPR, and it's being picked up by several different groups. Some conservation authorities are using some of it. We've seen some municipalities interested in it, and we're using it as the base of our methodology for this project. So I'll give a few examples of some of the work that's, some of it's specifically related to the Great Lakes Basin and others a little bit outside, but it sort of led us to where we have arrived to date, and hopefully some of the lessons that we've learned might be of interest to others that are in other jurisdictions looking at similar type of work. So the first initiative that we were involved in was back in 2011 that was coming out of the Lake Simcoe Protection Plan, which called for a watershed level adaptation plan. So out of that, MNR and our Ministry of Environment and Climate Change colleagues led a vulnerability assessment process to help inform that adaptation plan. So we looked at climate models and engaged experts to undertake modeling and other analysis on a variety of themes. Some of them are listed here, where they would come up with sort of key impacts or key vulnerabilities that they felt needed to be addressed and for adaptation options to be identified. We have produced several different climate change research reports. These images on the right are just examples of some of the reports. So each of the experts would have published one based on their theme. And we also then tried to document the process and the lessons learned from this adaptation planning process that was undertaken in this report, number 37, that you see the image of. So after the research was conducted on the vulnerability assessments, MNRF and OPR undertook sort of an adaptation recommendations process, and we identified I think it was over 900 different adaptation options that were then filtered down to a more reasonable number of possible actions. And I've listed the sort of themes: engaging people, reducing threats, enhancing adaptive capacity, and improving knowledge that the adaptation options were sort of categorized under. And one of the things coming out of this is that a bit of a reality check from the 900 potential options down to the few that might be actually implemented is there is a really good process there, and there's perhaps a benefit in reinforcing the separate roles of science and policy, and then managing expectations. So what could be done, identified in science, those 900 options, versus what will be or what may be done through policy and implementation are very different things. And it's important to remember that, and also important to look at it from both perspectives. I don't think I'll go into these lessons learned in any detail, and they'll be in my presentation, and they're also in that report that I just referred to on the slide before. One of the only ones I'll just touch on here, the two first ones, engaging stakeholders early and substantively. So having people involved in the process from the beginning was definitely something that we learned from that process, and we're trying to engage in more in this process we're into now. And scope, and I'll get into scope in a few slides, so just hold on that. So after the Lake Simcoe process, we moved on to another territory in Ontario because we wanted to learn more. So we applied the same methodology and broadened out the vulnerability assessment to include several forestry-related themes. So again, engaged researchers, applied climate models on a suite of themes, and this time there was work done on forest fire, on forest blowdown, on the composition and productivity of the forest, and on ungulates. And this work is now sort of entering into sort of the application phase where some of the results are being considered in forest management planning, for example, in the northeast part of the province. So how can they, when they're developing their next 10-year forest management plan, how can they take some of these climate impact results and factor that into the types of actions that they pursue in that planning process? I think we have some people on the phone, hopefully from Mississippi Rideau. This is another example of some work that's underway at a local level where MNRF is working with two conservation authorities in the Ottawa area to undertake a vulnerability assessment process. And you'll see how this ties into the Great Lakes Basin work in a second. But really, this is quite opportunistic. It's looking for conducting vulnerability assessments as funding and resources allow, and it's trying to connect in with some of the broader initiatives underway. And the interest of these two conservation authorities is to not necessarily create a standalone adaptation strategy, but rather to look at their policies and their existing procedures and guidelines and figure out how they can insert adaptation measures directly into existing documents. So it's kind of a neat way of mainstreaming adaptation right in, rather than having this own standalone document. Mississippi Rideau worked with us and OPR and Laurier last year on sort of a looking inward at their own organization type of project. And I just wanted to quickly highlight this here, that part of the success in undertaking adaptation is having an organization that has the capacity to be flexible and adapt to different changes. And so the idea of organizational readiness or adaptive capacity from an organizational perspective is a pretty important one. And so this Conservation Authority went through a bit of a questionnaire and open discussion process where they looked at the variety of different elements of their organizational structure and what were some of the strongest, their strengths and weaknesses in relation to how they can address climate change. So you'll see, for example, the red and blue are just averages. The strengths that the Conservation Authority felt that they had were, related to outreach, related to partnership, related to forums for outreach. So, other parts of their organization maybe are a little bit weaker and they need to make some adjustments of how they're structured to more adequately address climate change. So it was kind of a neat process, and the first time we tried to take a proactive look at this. So the last local initiative that I'll mention that's underway is in Peel Region, and this is involving multiple different partners. The region of Peel is a big proponent of it, and it's being led mostly by the Credit Valley Conservation and Toronto Region Conservation Authorities, with some help from a few others. And really this is taking existing literature from a review process and engaging experts in interviews to describe natural system vulnerabilities and the ecosystems, the implications for ecosystem services important to Peel Region. So, for example, Peel is very interested in flooding, and so they're going to try and look at flooding issues from a climate change perspective. So when you put all these pieces together, you can see that there's a lot of local initiatives happening, and they're happening at different scales. But what we see is that Ontario is a very big province, and it would be difficult to go at this level of detail, watershed by watershed or eco-district by eco-district. And so one of the issues that we've identified in this Great Lakes Basin initiative is addressing the issue of scale. So oftentimes this vulnerability and impact science is often developed at scales too small for effective application across jurisdictions, and that what it results in is that information is difficult to aggregate across larger geographic areas. So oftentimes this leads to duplication, or it leads to confusion over what the results are telling us. One of the opportunities there we saw is to integrate and nest information at sort of, as best we can, at local to regional scales for a variety of uses. The second thing that we noted from all of these experiences to date is related to collaboration. So there is some interagency collaboration happening on adaptation issues, but there are a lot of different organizations that are interested and willing to jump into this sort of field. And so the opportunity here is to try and collaborate and bring experts and interested organizations together to advance adaptation efforts collaboratively. Just on that, another look at this. So that as I said, there's many organizations that are interested in conservation in Ontario, and the challenge is really to develop this vulnerability assessment information at scales and levels that are meaningful to a variety of jurisdictions. So I'm just going to layer on jurisdictional boundaries. So we have our ecoregions, we have our MNRF districts, we have conservation authority boundaries, and we have municipalities. And I'm sure I could layer on another 10 different boundaries if I wanted to make the map messier, but the point being, each of these different agencies and organizations will have different interests, but many of them are common interests. And so how can we develop information that is meaningful to all these different types of groups? So, so with that sort of assessment of where we were, we decided that we would try and look at a regional scale. We take the Great Lakes Basin, given a lot of the drivers under the Great Lakes Water Quality Agreement. And so we developed a project to provide integrated state-of-art climate change science, information, and outreach to natural resource users and communities in the Great Lakes Basin, attempting to be as strategic and collaborative and cost-effective as possible. So our timeline is 2014 to 2018 under the current Canada-Ontario Agreement on the Great Lakes. And our approach is using the vulnerability assessment methodology that I spoke of and applying it to the basin, and also applying it at more local levels. So looking at each Great Lake drainage basin, and then where possible, even more local if there's interest, like at a conservation authority. So the streams that we're involved in right now are sort of threefold. So we've got the climate change vulnerability assessments that we are funding, and here's just a list of some of the ones that are currently underway. We will likely see some more emerge over the next couple of years. And I'm going to give you a few examples of from the aquatic habitat and the fur bearer landscape connectivity examples, just in terms of what type of information are these assessments providing. So the aquatic ecosystem vulnerability assessment has been primarily completed, pretty much completed, and this is an example of the output from it. So it looked at multiple different indicators from a wetlands, a streams, and a lakes perspective. And on your right, you can see an example from one of the indicators in streams, which was stream temperature. And it looked at the current maximum weekly average temperature across the Great Lakes Basin, and then what the change in that maximum weekly annual average temperature would be under different climate scenarios. And this is just for the end of the century, but data for a variety of time periods and for several different scenarios. The researcher that conducted this was then able to, given the interest in Mississippi Rideau that I spoke of, she was able to meet with those practitioners and seek additional data layers from those watersheds to build into her model and validate and provide information at a more local level. So these are maps of the same indicator of maximum weekly average temperature of streams for the Mississippi and Rideau watershed. So for people at that level, they felt like the information was made relevant to them and that it was validated with their information. Another example is habitat connectivity. So this is a really interesting one. We know that habitat loss and fragmentation are significant threats to wildlife. So when you have reduced connectivity on the landscape, species aren't able to move around well enough, and so low connectivity would increase the vulnerability of species. So this is a methodology that a researcher, Jeff Bowman, has pursued, looking at a multi-species connectivity mapping product using something called circuit theory. And he's used this successfully to measure different fur bearers' abilities to move around on the landscape given their habitat. So a second stream of this project is climate modeling. So as we all know, climate modeling continues to march along and advance, and we're trying to make it as accessible and useful to practitioners as possible. So one aspect is to ensure that we're integrating the most up-to-date climate data, so from Assessment Report 5 from the IPCC, but also to collaborate with other organizations on producing climate data products, whether that be maps, tools, questions and answers, training, that are useful for sort of removing that barrier to engagement, which is, what the hell do we do with this information? I'm confused by what data sources I should use. What does this data tell me? So we're trying to provide some support there. And then the third stream is adaptation planning. So where we see this going is working with partner organizations, resource users, and communities to use vulnerability assessment information in adaptation planning efforts. So we've got several local initiatives that I've mentioned underway in the Great Lakes Basin. We all work with those groups, as well as any other willing and interested groups that would like to sort of consider climate change in the work they do. There's these examples, these snapshots at the bottom of the slide are just examples of adaptation planning products that have been developed in the US that are quite interesting and that we're looking at. So I won't go into any detail there. The only other point I'd like to make is that we've recently formulated something called the Climate Adaptation Network for Ontario Ecosystems, the acronym being CANOE, which really brings together multiple organizations that are interested in conservation and climate change in an Ontario perspective, so that perhaps we can better collaborate on the integration of climate change adaptation into the work they do. So hopefully this group will be able to sort of advance adaptation planning and adaptation efforts throughout the basin through collaboration. So I've listed the members here, and as you can see, this image of the people in the canoe, we're trying to bolster our efforts by working together and advancing as best we can collaboratively. So I'll wrap up here just with some final thoughts, and really these are stolen directly from a colleague at the U.S. Forest Service, Chris Swanson, and I thought they were really a great way to capture some of the challenges and opportunities that we see with a project like this and where we're trying to go. So one of the things is we need to provide coordination. So change, and climate change specifically, is a very challenging nut to crack, and it takes effort, and effort takes attention. Everyone is busy, so by providing a coordinated effort, we can hopefully make we can provide that support and make some headway. Another piece is the scale issue. So science and management should inform each other, and you need both top-down, sort of regional and downscaled information, but you also need that bottom-up, place-based information. So the expertise and the knowledge that people have in their own backyard, in their watershed, is just as important, and finding ways to integrate those two perspectives will be very important. And then just finally, that climate-informed decisions are typically about people and places, not actually about climate. So we need to work with people about what their objectives are, what are they trying to manage, and what are their end goals, and help them do their job better. So not trying to create a whole new process for them, but work within their existing structures and their existing objectives to achieve them. And really on that note, just learning by doing and learning together is really the way that we're going to make strides in this field. So that's the end of my presentation, and I'd be happy to take any questions or comments at this point.
Okay, great. Thanks so much, Jenny. So we now have about 15 minutes or so left for questions. So if you do have any questions or comments for Jenny, now is the time to ask. Again, if you would like to use the chat box, please feel free to go ahead and type out your question, and I can read it out for everyone. And if you're on the conference call line with us and would prefer to ask a question over the telephone, please go ahead and hit *6 to unmute your line. So Jenny, we had a question in the chat box earlier. I'm not sure if you had seen it, but Rod McRae was asking about the anticipated timing for the vulnerability impacts summary report.
Okay, hi Rob. I think that we'll start to be producing this information in the next year, though I think like a synthesis report probably is a couple of years out, but our intention is to try and get as much of the information out as quick as possible, given that there's a lot of interest in this. So producing individual studies, whether they be in our climate change research report series or in peer-reviewed literature or as a tool itself, we're going to try and use some of the examples I gave, like the aquatic habitat one, is the study is virtually complete, so we just really need to get it out the door and into people's hands. So I'd say portions of it in the next year or so, but in terms of a summary report, I think we're a couple years out.
Okay, thanks, Jenny. I don't see anybody else typing right now. Is there any questions on the conference call line? If so, please just go ahead and hit *6. Give everybody a few seconds here. Well, I have a question for you, Jenny, and maybe others will come up with some questions during that time. So have all the research projects underway as part of this project, have they been completed in a consistent way so that the results can be aggregated and compared?
Well, that's sort of one of the core, I guess, principles in what we're trying to do, is that trying to provide some basic standards and consistency across the project so that you can essentially roll them up together. So some of the things that the ways that we're trying to make that happen, one of them is some consistency in base data. So, things like the basic ecological data for the basin that they're using, making sure that it's the same. Standards for, at least at a minimum, using the same climate model scenarios and timeframes. Even that is a hurdle. Sometimes a different time frame will be selected, and it pretty much just kiboshes the ability to roll things up.
Right.
And then reporting units. So we've sort of been struggling with this one a little bit, but trying to make the reporting units consistent. So we've asked all researchers to provide results both at the basin level, at the lake drainage level. So that's 5 different reporting units, like a Lake Ontario. There'd be a Lake Ontario report. So, watersheds in the Lake Ontario drainage basin would find that report the most useful, obviously. So 5 reporting units at that level. And then I've mentioned these local initiatives, mostly at conservation authorities. But if there are those, we're going to try and endeavor to work with those local initiatives to, where possible, provide information at that scale as well.
Okay, awesome. Very interesting. Thank you.
I think, the one last thing I would say on that is there's some effort, you can see elsewhere to provide spatially gridded products that then are just able to be rolled up no matter what. And it's kind of a big thing to embark on, to do something like that, but we're definitely toying with that idea as a simple way of scaling up and down and being able to nest information.
Okay, awesome. Perfect. Okay, I see some people writing, so I'll just give a couple more seconds and see if anybody else has any questions.
Carolyn O'Neill from the Ministry of Environment and Climate Change Great Lakes Office. That was a fabulous presentation. We wondered if you could say a few words about the traditional ecological knowledge project we saw on one of the maps.
Yep. Yeah, sorry, I didn't touch on that at all, Carolyn, mostly just because it's not in the basin. But that one star that the map showed isn't representative of where the work is being undertaken, but that is the work that is primarily being led by Dr. David Pearson at Laurentian, and he's associated with OKR as well. But what he's doing is it's quite a neat process of engaging a handful of First Nations communities in the far north in a sort of bottom-up identification of observed change to date. So he's developed a neat interview process that he works with the band leaders, and usually he has someone from the community lead these interviews, mostly with elders, to identify the changes that they've seen in the bush, in the water around them over the past number of years. And then from there, think about what climate change may mean, including looking at climate models at a sort of high level. So he's developed a little bit of a adaptation planning process, very similar, but just a little bit more founded on traditional ecological knowledge.
Excellent, thank you. We might follow up a little bit more on that one.
Okay, thanks, Carolyn. Johnny, we have a question in the chat box from Rob McRae. So he asked, do you know if the Ministry of Environment and Climate Change will be supporting similar research on topics such as air and water quality, noting the new name of the ministry? And obviously, thank you for a very informative talk.
I know I have several colleagues here from Ministry of Environment and Climate Change, so I will let them chime in. All to say, I think given their name change, there's definitely an interest and a strong mandate in that ministry to lead climate change issues, and they have research capacity there. So I would expect so, but maybe I'll open it up to my colleagues over there to mention anything that they are aware of. Carolyn or I don't know if John Liu is on the phone. Do you guys have any comments on that question?
It's Carolyn. I'm on the policy side, and I know there's work going on, but I'm not as in a position to really speak to anything in the kind of detail I think that might be helpful on this call.
Okay.
Okay. All right, well, thank you. Okay. All right. Any other questions on the conference call line? Any final questions at all? I'll just wait a couple more seconds here just in case people are thinking right now. I see some other people writing, so we'll just wait a couple seconds here. Okay, if there are no other questions, obviously, Jenny, are you able to take emails and calls if people have further questions about your presentation today?
Yeah, for sure. And I guess just a call out to people that, as I said, this is really just at the beginning of a journey, and we're trying to make this as useful and meaningful to as many audiences as possible. So if there is particular interest from any organization that wants to explore how they might be involved or how it might be useful to them, we can set up a meeting or a call, no problem.
Okay, that's great. Perfect. Okay, well then I guess we'll wrap things up here. So I'd like to thank everyone for joining us today for the FACOP webinar. We hope you enjoyed it. Obviously, a very big thank you goes out to you, Jenny, for your time and effort and for a great and informative presentation. Any last comments from you before we sign off here?
Nope, that's fine.
Perfect.